Hello, good morning, doers. Good morning, Camp Cavallo. I'm Ariel Ekblaw, and I lead the MIT Media Lab's Space Exploration Initiative. I'm here today to tell you about how we are aiming and trying to democratize access to space exploration. If you think about Elon Musk and Jeff Bezos and ESA and NASA building the rockets to get us there, wherever there may be, Mars, Moon, or beyond, we are thinking about what is the human lived experience when we are there? What are the tools, the technologies, the experiences that will empower humanity as we are at this cusp of interplanetary civilization? But importantly, yes, this is a sci fi space vision future, this is thinking about space exploration. How can that same suite of technologies come back down and be used to profoundly benefit life on Earth? And the reason that we believe in this is two really compelling analogs. The first are the beautiful similarities between deep ocean, deep sea, that we've heard so much about this week, and deep space. Thinking about designing for one often has analog applications in the other. And the second is the analog between resource-constrained environments, say the International Space Station, and resource-constrained environments on the Earth, like refugee camps and areas torn by natural disasters. And we see a natural application for space-based technologies to be used in this context. Our vision for the Space Exploration Initiative is to be building something of a Starfleet Academy. Now, who here is familiar with Star Trek or the notion of Starfleet Academy? It's this idea, it's where the space cadets go to learn and to build the artifacts of their sci-fi space future. But in this moment in time, we need a Starfleet Academy not just for moonshots, but one in equal service of moonshots and Earthshots. And the mission of democratizing access to space and these Earthshots means that the Media Lab, we're thinking about the context of Earthshots and moonshots, and how do you bring this into the purview of hackers and makers and communities traditionally excluded from space and young people, that Gen Z that Joey was talking about. This is our outreach program to try and bring space hacking to a new generation. So we started this program here, I say here in Boston because I'm usually speaking in Boston, out in Boston, back in Boston, with 20 local high school students focusing on underrepresented minority communities. They will be going through the process, the entire life cycle of a proper spacecraft. So what I'm holding here is a 2-scale model of the spacecraft that these students will be building. They are designing, building, testing, launching, flying, and analyzing data from their own CubeSat. Now, critically, we've decided to theme this around climate science. And this was a point of inspiration for Maria Zuber, who's sitting in the audience, saying it's much harder to be a climate science denier if your kid or your niece or your friend's best friend down the road is engaged at a fundamental level in something that seems innocuous that you can become to believe in. And so we're focusing on the youth and thinking about how do we get them and the next generation engaged in the investment in the future health of their planet, or as Andy would say, measuring the treasure of their own Blue Island planet home. Now, having just a few students outside of Boston with the MIT support build a CubeSat is honestly not particularly innovative. There are plenty of student groups that are doing this around the country. What is innovative and what we're working with Emerson on is how do you scale this curriculum, this opportunity for young kids, for high schoolers to build their own spacecraft across the entire nation and eventually internationally. So what we're working on is the curriculum, the modularity, the tech development, the support for free launches through NASA, so that not just coastal cities and places where you live near MIT or Stanford or Caltech can build a CubeSat in a high school classroom, but as Andy would say, purple states, blue states, red states, middle America, scaling through public libraries, through makerspaces, through XQ and their high school network, and making this something that an entire generation can really experience, building their own spacecraft hardware, democratizing access to space, and contributing to science about the future of their own planet and climate change. For those of you who are still wondering what exactly a CubeSat is, come on Saturday. We have 70 or 80 students who are coming to Camp Cavallo to build models of these CubeSats. I'll actually pass this around if you guys want to see a real scale model. And basically what a CubeSat is a small piece of hardware. You can see it's about 10 centimeters on each side, where you have different subsystems, right? So you have solar panels, you have a science payload, a different printed circuit boards and electronics to make a function, and it all fits in this incredible modular platform that is used for real science. It's not just an educational platform, but we are making it into one. You saw this slide just briefly in Joey's presentation. This is our first cohort of students. You can see Danielle Wood there, who's a new faculty member at the Media Lab giving our inaugural lecture. They're actually working with real CubeSats down in the photo on the bottom left, and that model that's being passed around is what the students tomorrow will be building and exercise around designing the subsystems and the use of their own CubeSat. A core focus of any outreach program is usually the learning and the doing, but there's a phrase that I've inherited from my 2 Air Force pilot parents who did a lot of training and flights for the Air Force. Learn one, do one, be a doer, and then teach one. And so what we are finding is unique about this program is not only are they learning to build a CubeSat, not only are they building a CubeSat and actually deploying it, but we are going to have them pay it forward. So we do this in 2 different ways. One, they will be teaching their own peers. So these young students, these high schoolers, become ambassadors in their own community, helping us spread the curriculum and engage more and more people in the work. And finally, they're going to teach the adults. We host a major space event at the lab now every year. We bring about 60 leading space visionaries. Katie Coleman, we've been honored to have her before. She's here in the audience. Astronauts, people from Hollywood, producers, Neil Stevenson, and sci-fi authors. And these students from the Climate CubeSat CoBuilding initiative are going to come to this event and other events throughout the country and teach the adults what they have learned about building CubeSats and engaging with climate science and climate data. And finally, what I'd like to do is just show you a bit of a peek into the rest of the Space Exploration Initiative. The Climate CubeSat CoBuilding program is our capstone outreach project, but we're also a team of 50 students, staff, and faculty, and 25 different research projects in the portfolio. Sometimes we have an interesting philosophy at MIT of focusing on just the technology and the engineering, but this is an artist. This is Annie Liu. And what's unique about doing this work at the Media Lab is that it's anti-disciplinary. It unites engineers, artists, scientists, and designers on the future of science fiction space prototyping, on the future of democratizing access to space. And when we were doing our first zero-gravity flight, we were going to deploy 14 different research projects that year in 2017, Annie Liu came to me and said, hey, I don't want to do a fancy piece of space hardware. I don't want to do a sci-fi space prototype. I want to take the sense of the ocean, grass, dirt, and my partner, and I want to place them in this space context and honor the sense of Earth. We want to celebrate the smells and the natural environment of Earth in this very first inaugural space simulation that we did in zero gravity. And so this is thinking about and leading us to imagine, what does it look like to take a bit of Earth with us on a space voyage? What does it look like? What does it mean to do an incredible, long and dangerous and difficult voyage like we heard about from Nainoa and the Wayfinders yesterday? And it reminds us to always remember and infuse the values of preserving the Earth in everything that we do across the future of space, moonshots, and Earth shots. Thank you so much.